Hello guys! You like to share various scenarios about the extinction of humanity, the Earth, or even the universe, right? Therefore, today we brought a theory about the end of the universe for you. Will the Earth become dust billions of years from now? And will other celestial bodies in the universe also have the same destiny? Welcome to our Wikivedia Plus channel. Are you ready? Let's tell everything from now on. So let's get started. The mystery of the supernovae. When the Big Bang theory was accepted by the scientific community, no one else doubted that the universe was expanding. Based on elementary logic and the laws of physics, it is believed that the speed of expansion of the universe should gradually decrease. This is because the initial momentum of the Big Bang should weaken over time. It was only in the 1990s that scientists made some discoveries that did not fit into the conventional view, and this idea has remained in fashion for several decades. To explain the essence of this, it is necessary to talk a little about how scientists determine the distances to distant galaxies, and how they determine the speed with which galaxies move away due to the expansion of the universe. Well, there is a phenomenon called redshift. As celestial objects emit light and move away from the Earth, the spectrum of that light shifts to the red part. This is known as the Humboldt law, and in simple terms it means that the further away a galaxy is, the redder it appears. However, to accurately measure distances to distant galaxies, it is necessary to have something like a reference point. To calculate the distance, we use celestial objects whose luminosity is precisely known. These objects are called standard sail astronomy. We select some supernovae whose intrinsic luminosity is almost constant, and using the decrease in its luminosity, we can calculate the distance to a celestial object. Of course, for this, we need to observe supernovae in distant galaxies. At the end of the 1990s, scientists noticed the existence of supernovae in distant galaxies that seemed darker than the brightness previously calculated for them, although their distances were already established. This means that galaxies are moving away from the Earth at a speed greater than the distance initially calculated. In other words, the universe is not just expanding, but expanding at an accelerated rate. This discovery caused a great sensation, so more evidence was needed. And this evidence was found when investigating cosmic background radiation in microwaves and several other phenomena that are remains of the Big Bang. In this way, humanity has acquired knowledge that some force is accelerating the expansion of the universe, marking the beginning of the new 21st century. In other words, contrary to what the old model suggested, the speed of expansion of the universe is accelerating instead of decreasing. The cause of this phenomenon was completely unknown. It was then that this cause was compared to dark matter and received the name of dark energy. What unites us? Subsequent research has revealed that dark energy is distributed almost uniformly in the cosmic space, which does not interact with common matter or dark matter, and that it has an anti-gravitational effect, that is, a repulsion effect instead of attraction. In addition, it became clear that most of the composition of the universe, about 3/4 of it, is composed of this dark energy. This is related to the fact that dark energy is everywhere. Like common matter, dark matter also groups to form structures. Within these structures, vast empty spaces extend, with light years of cosmic space between stars and galaxies. On the other hand, as mentioned above, dark energy is everywhere. Naturally, the following question arises. If the universe is expanding, and the dark energy that contributes significantly to this is present everywhere, why are only the most distant galaxies moving away from the Earth? The answer is simple. Our galaxy, where we live, the Milky Way, is part of a gigantic structure known as the local group, which is made up of many galaxies united by gravity. Even larger structures, such as clusters of galaxies, walls, and galactic filaments, are interconnected by the force of gravity. But so far, dark energy is not strong enough to overcome gravitational force. For example, the reason why the Andromeda Galaxy is approaching the Milky Way instead of moving away is this. On the other hand, distant galaxies are not connected to the Milky Way in any way. Therefore, as the universe expands, distant galaxies move away from the Milky Way. So far, everything seems to be going well on a super-agglomerated scale of galaxies. However, what will happen in the future? According to scientists' calculations, dark energy began to expand the universe rapidly just about 5 billion years ago. As mentioned above, since then we must not forget that the speed of expansion has continued to increase to the present. As time goes by, due to the expansion of the universe, distant galaxies will begin to disappear completely from our vision. The speed at which they move away from us increases, and the galaxies become even more reddish. At a certain point, this relative speed will exceed the speed of light. And at that moment, these galaxies will surpass the event horizon for us. The light emitted by these galaxies will not reach us, and no matter what spaceship we use, it will no longer be possible to reach them. Next, the closest galaxies will also begin to disappear. In the end, we can only observe and investigate our own superagglomerate, which is one of many ships being taken in separate directions by the universe's current. What will happen after that is unknown. However, the star's lights will eventually go out, new stars will no longer be formed, and the autumn of the superagglomerate will come. What remains after that is the thermal death of the universe. The Great Collapse. For those who found the previous image disheartening, be prepared. For all of you, there is an even worse scenario. What we saw in the previous session is limited to the case in which the action of dark energy does not exceed gravity. That is, it stops at a specific limit. However, if there is no limit and the universe continues to expand more and more rapidly, the devastating scenario that awaits us is known as the Big Rip. Dark energy begins to overcome all the forces of connection over gravity. Now, when the Big Rip occurs, the first warning signal is similar to the previous scenario. The entire observable universe outside our superagglomerate disappears beyond the event horizon. However, unlike the previous scenario, the destruction of the universe does not stop there. The weaker the connection of gravity, the more easily dark energy prevails. Therefore, first, clusters of galaxies and massive structures of the universe crumble. The galaxies remain isolated from each other, eventually ceasing to be visible to each other beyond the event horizon. Then, the force of dark energy begins to disintegrate the galaxies themselves. This process occurs at a very slow rate, about 10 billion years, but it cannot be avoided. Dark energy gradually stretches the galaxies over time. Therefore, initially, distant stars begin to move away, followed by the stars closest to us. In the end, the galaxies disintegrate completely, leaving only isolated stellar systems. The night sky of these stellar systems will be empty. Only satellites and other planets will shine. The era of isolated stellar systems will continue for another 60 million years. In the meantime, dark energy will begin to do with the stars what it did previously with the galaxies. That is, first it will stretch the most distant celestial bodies, and then it will gradually tear them. Finally, the stellar systems will be completely destroyed. The only force that can still resist the destruction caused by the expansion of the universe is the one that connects celestial bodies and atoms. However, the speed of expansion increases even more, and the planets only last 3 months. Due to dark energy, the planets are torn apart, first in dust, and then disintegrate into molecules and separate atoms. The last sigh occurs first with the disintegration of the molecules, and then with the complete disintegration of the individual atoms. That is, the interactions that keep the molecules and atoms together will be lost, following gravity. When the last atom disintegrates, the era of the Big Rip begins. The universe will be composed only of elementary particles that cannot interact with each other. This is because elementary particles continue to move away from each other at relative speeds greater than the speed of light. We do not know how the chaotic movement of these particles will end up in the places where stars, planets, and galaxies used to exist. However, it seems evident that life will no longer be able to exist. Well guys, with that, today's video comes to an end. Thank you all for watching to the end. Now tell me, were you scared? Take a deep breath. First, even if something like this happens, it will occur in more than 22 billion years. We, like the Earth and the Sun, will not live that long. In addition, we still know very little about dark energy. Who knows, maybe even dark energy will run out and stop expanding the universe in an accelerated way. Therefore, I think it is too early for us to be scared. If you like this video, we would be happy if you could like it and share the video on your social networks. We have always appreciated your support. Now let's get ready for the next video here on our Wikivedia Plus channel. We'll be back soon. A big hug, and until then, bye.